Welcome back to Monroe Live, everybody. Today we have our 4680 battery cell completely tore down. We have Antonio here to walk through his disassembly process. And we found a couple interesting things. So what do you want to start with?
Let's just start with the disassembly itself. So easiest way to get a can like this is just to take a pipe cutter, go around the rim. This is a rather thick piece of steel, so it was not easy, and I had to do a couple traces and get the same path for each time around, but it worked and we got eventually through the can. So we started with the negative end because you wanted to actually disconnect the electrical connection inside the cell so you don't have any shorting.
Now let's talk about the negative end. So I see some remnants of, what is this, just pure copper or some sort of copper blend?
Yeah, this is pure copper.
Now this is trapped in the, was it a swaging process on the bottom?
Right, so this is a press lock with, there is a lip that gets pressed in using the outside of this gasket, and it presses the metal to metal contact of the wall of the can so that the anode material here is in direct contact and provide you a circuit.
Now I don't remember seeing this during the battery day presentation. So we're all familiar with seeing the jelly roll rolled up and all these small little tabs creating one giant, tab overlay.
Right.
And if you look at this right here, you can see there's on the back side, you have all these little laser weld marks. So there's one long one in the center, two slightly shorter ones on the outside, and then two little ones right there on each of these 6 little, flower petals. And on the other side, you can see where they actually welded 2 different chunks of the tab. So when we call this a tabless battery pack with battery cell, what they mean is it doesn't have one singular tab. It uses this large group of tabs all laser welded to this little piece. Now, I don't remember this being a part of the process. So can you talk through what this is doing?
All right, so in a typical cell, you have one tab with a piece of metal that goes down and is connected somewhere into the middle of the actual jelly roll, and it draws current from that one spot. The problem is when you get to a very long roll like this, you end up getting heat concentration at that point, and that can be a failure point in charging and discharge cycles. So Tesla went with a all tab process, except for the fact that there's no laser weld in the middle. It's a single strip of copper coated on both sides with the graphite.
And then this piece was added because what they couldn't weld it to the bottom of the can, is that what it was?
Right, so they don't have it's hard to make that weld. So there's a small rivet here to hold everything in place. This just slips right over it. That might be a pressure relief. It might just be that this is a pressure relief. We're not sure. We're going to have to model that to find out for sure.
Yeah, and we also have 1 or 2 of these cells. We did CAT scans.
Yes.
So before we disassembled it, we did a CT scan with one of our partners called Kinetic Vision down in Ohio, a great partner. If you ever need CT work, shout out to them. We may pop up a little image of that CAT scan. We have it back yet?
Yes.
Yeah. So we wanted to see how the cell was all assembled before we dug into it. Now, the other side, so you said this is the
anode, because copper is a more noble metal. It'll be more resistant to corrosion in anodic environments.
Yeah.
So aluminum is better for that cathodic environment where it's not going to corrode. It's actually kind of protected.
Okay. And on the top of the battery cell, you have a similar piece right here with the same type of laser welds. Let me flip it over. In the exact same pattern. But what's interesting here is you have 6 little tabs, and they're actually connected on the outside over here instead of coming from the center. So a slightly different design, but this is aluminum being welded to aluminum. This is copper being welded to copper, and similar methodology. And what's this in the center right here?
So the reason we don't have that outside ring, which was attached to the crimping, is we have a small rivet that attaches to the top positive terminal. And that was either welded or stamped into place. We're thinking it might be a stamped process at this point, so the process would be these would be welded on to either end of the jelly roll, and then this is either welded in and then stamped into the positive terminal, or laser welded into the positive terminal. I think the stamping would be an easier process.
Yeah. And this right here is essentially an insulator that probably goes,
Right. So you want to avoid having
this touched the can.
right.
Because if it touches the can, it would short out because the
Right.
can is negative.
Exactly. So that's an isolator to keep anything from short circuiting within the anode to the cell, or cathode to the cell, and the cathode is just a tab.
And then this piece right here,
That's an insulative gasket.
gasket. So this not only seals the electrolyte in, it makes sure that this aluminum piece on top, right here, is that aluminum?
Yes.
Doesn't touch the stainless steel outside of the can. It fits right there.
Right.
So we're hoping that you're getting a real nice close-up shot here so that we can see all the little bits and pieces. And these 4680 cells have essentially captured the attention of the world. It's been the thing that's drawn the most interest to Monroe Live, probably in the past 2 or 3 years, only to probably be surpassed by the Cybertruck whenever we get one of those. It was a tremendous amount of effort to get this cell out of the modules and the pack itself. But now that we've dug into the cell, it's amazing to think that each one of these cells has so much fragile material. So it really relies on it being wrapped up really tight together. Can you talk about some of the thermal expansion and issues that you would have and type of scrap rates? Because just touching this right here, it just essentially falls apart.
Yes. The cathode material is pretty brittle. It's the NMC compound, so it's a metal oxide or just metal itself pressed together, usually with some type of binder, and that's bonded to an aluminum film. So if it's a dry process, it's going to get rid of the binding step or solvent binder, and it's going to use a fibrillated fluorocarbon as a material to hold everything together, which is more what the anode looks like. So this is graphite, and it's really staying together well. It's bonded to the copper strip as well. I think it's like 0.3 mils. This was 0.17 millimeters in thickness. But yeah, that still includes a layer of copper, 2 layers of graphite, layer of aluminum, 2 layers of your cathode material.
Yeah. And Antonio, we have a X-ray spectrometer, which we use to figure out the composition of the anode and the cathode.
X-ray is not going to tell us much on the anode side because carbon is
Yeah,
invisible pretty much. But yes, we were able to get good analysis on this. It is an NMC 8:1:1-ish ratios.
Okay. Yeah, and at Monroe & Associates, like I mentioned before, we rely on our engineering analysis and the sales of our reports. So if you're out there and watching this teardown and you want to know all the specifics, the thicknesses of the metal, the composition of the metal, the composition of the separator, the thicknesses and lengths of everything, the specifics on the laser welds, we are creating a small report on this battery, which will be available for sale if you just email us at sales@leandesign.com. Probably not going to be available right away, but we'll keep you posted. So this was relatively easy to get apart, and we waited a while. We wanted to make sure that we got all the cells out of the pack. We probably could have done this 3 or 4 months ago, but we're so astronomically busy here at Monroe & Associates that it kind of almost took a back seat. And once you got it apart so quickly, we thought we'd do a video, and I want to thank you for running through this. Thank you for getting this apart.
It's a pleasure, and it's we also wanted to make sure we followed all the safety protocols.
Yeah.
And the big thing for the cell, everyone's worried about it going thermal and shooting fire and sparks everywhere. We took all the precautions to avoid that, and it made the disassembly pretty easy.
Yep.
And we should have video of that. I don't know if we're going to include that.
Sandy will weigh in next week. He is in San Diego. He'll be at the Fully Charged EV show, as well as myself. This video will most likely be airing after that took place. But that's why Sandy's not here. Sandy will want to weigh in when he gets back. So we really appreciate everybody watching Monroe Live.